Hi everyone. In this session, we are going to discuss reaction of metals with acid, displacement reaction. These two topics are very important in the exam point of view. You can expect one or two questions from this session. Let's start the discussion. Reaction of metals with acid. If there is a reaction of metal with acid, there will be production of hydrogen. H2 is essential in this reaction. Metal plus dilute acid gives salt plus hydrogen. Here, this hydrogen is common. In every reaction, there will be production of hydrogen. Metal plus dilute acid gives salt plus hydrogen. It is a general equation for this reaction of metal with acid. Let's discuss some of the examples. First one, 2Al. Here aluminium is reacting with hydrochloric acid. Al plus HCl. Al plus HCl, the product which we are getting is aluminium chloride, because here we are taking HCl and it is aluminium, so we will get aluminium chloride, Al plus Cl, aluminium chloride, and we are going to get hydrogen. Hydrogen is a common factor. 2Al plus 6HCl gives 2AlCl3 plus 3H2. It is a reaction of aluminium with hydrochloric acid. Then what about next metal? If we are considering other metal, zinc plus HCl. Here it is zinc and HCl. So what will be the product? It will be zinc chloride. If it is aluminium, it will be aluminium chloride. If it is zinc, it will be zinc chloride, ZnCl2 plus H2. H2 is a common factor. So reaction is Zn plus 2HCl gives ZnCl2 plus H2. Next one, Fe plus 2HCl gives FeCl2 plus H2. Here also we are getting the same product. Here the metal is Fe, iron, we are getting FeCl2 and we are getting hydrogen gas. Hydrogen gas is a common factor. Next example, Mg plus 2HCl gives MgCl2 plus H2. In all of this reaction, hydrogen is common factor. Here in all reaction, there is a production of hydrogen gas. If there is a reaction between metal and acid, we are going to get hydrogen and its salt. Here AlCl3, ZnCl2, FeCl2, MgCl2, these are the salt. If you are taking sulfuric acid, it is H2SO4, it will be Al2SO4 thrice, ZnSO4, FeSO4, MgSO4. Instead of Cl, we will get SO4. That's a difference. There will be production of salt and production of hydrogen. We can conclude that metals react with acids to give its salt and hydrogen gas. If there is a reaction between metal and acid, we are going to get salt of the metal and hydrogen gas. Nitric acid. There is an exceptional case, nitric acid. It's a very important question. Nitric acid is a strong oxidizing agent. What do you mean by the term oxidation? Oxidation is addition of oxygen. Nitric acid is an oxidizing agent, means it will help the other element to add oxygen. For example, if it is H2, nitric acid will help them to convert into H2O, means addition of oxygen to H2. Here, this nitric acid is a strong oxidizing agent. It is a strong oxidizing agent. It will help for oxidation. So what is going to happen when there is a reaction between a metal and nitric acid? Let's see that. Here, the H2, if there is a reaction between metal and nitric acid, we are going to get H2, because nitric acid is an acid and there is a metal also. So metal and acid, we are going to get H2, but here this H2 is going to convert into H2O, because nitric acid is an oxidizing agent. It will add oxygen to H2 and it will convert into H2O. It is a specialty of nitric acid. Nitric acid is not going to give hydrogen gas, because nitric acid is a strong oxidizing agent. It is oxidizing hydrogen to form H2O. Oxidizing hydrogen to make H2O. Now we can write the explanation. Nitric acid won't produce hydrogen during the reaction with metals. The reason is nitric acid is a strong oxidizing agent. Nitric acid is strong oxidizing agent. It will oxidizes hydrogen to water. Itself gets reduced to any of the nitrogen oxide, nitrous oxide, nitrogen monoxide, nitrogen dioxide. If we are taking dilute nitric acid, concentration should be very low. Dilute means the water content is more and acidic content is less. Means the concentration of acid should be very low. We are going to get hydrogen. If there is a reaction between dilute nitric acid and manganese, we are going to get hydrogen. Magnesium and manganese will react with dilute nitric acid to give hydrogen. Next topic is displacement reaction. Displacement reaction is a very important topic. There will be equation from this session. You need to complete the reaction, or you need to define the reaction, you need to identify the reaction. This kind of question is going to come from this session. Displacement reaction. What do you mean by the term displacement? Displacement means, here it is replacement. Here you can see two balls. Here there are two balls, and this ball is going to replace one of the balls from here. That is called displacement reaction. This reaction is known as displacement reaction. Now one ball has been removed by other ball. Let's discuss one of the example. Here you can see a key. It is made up of iron. It is iron, and here we are taking copper sulfate solution. It is copper sulfate solution and it is iron. When we are adding this iron to copper sulfate solution, what is going to happen? Let's see that. We are going to add this iron to copper sulfate solution and we are observing the solution. What's your observation? You can see that color of copper sulfate solution is changing and color of that iron is also changing. What is the reason behind it? Here you can see it is copper now on the surface. On the surface of that iron, you can see deposits of copper and the solution has been changed to ferrous sulfate solution. It is a displacement reaction. Let's discuss it again. Here we are adding iron plus copper sulfate solution and we are getting copper on the surface of the iron and we are getting ferrous sulfate solution. This reaction is known as displacement reaction. Iron plus copper sulfate solution gives copper plus iron sulfate solution. Here it was copper sulfate solution. Here it is copper sulfate solution, isn't it? After the reaction it is ferrous sulfate solution. Here it is iron and after the reaction it is copper. In the reactant side and in the product side, just compare it. If we are comparing the reactant side, iron was alone in the reactant side. But after the reaction, iron has been combined with sulfate. Here it was copper sulfate and after the reaction copper is alone. Here iron is replacing copper. Iron is more reactive than copper, so iron can replace copper from copper sulfate solution. This reaction is known as displacement reaction. It is a process of replacing one element of a compound from its solution by other element. Iron plus copper sulfate solution gives copper plus ferrous sulfate solution. It is the best example for displacement reaction. Next one is reactivity series. It is an arrangement of metals. Some metals are highly reactive, some metals are less reactive. Reactivity series is an arrangement of metals on the basis of their reactivity. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. It is the order. You need to learn that here potassium is more reactive, gold is less reactive. It is a decreasing order of reactivity. When we are coming down, the reactivity is decreasing. So more reactive element is potassium, less reactive element is gold. Let's write the symbols here. K, potassium K, sodium Na, Ca, Mg, Al, Zn, Fe, Pb, lead is Pb, H, hydrogen, Cu, copper, Hg, mercury, Ag, silver, Au, gold. So this arrangement is known as reactivity series. So what do you mean by reactivity series? Reactivity series is the arrangement of metals on the basis of the reactivity, and when we are coming down, the reactivity is decreasing. More reactive element potassium, less reactive element gold. It is the arrangement of metals on the basis of their reactivity. Displacement reaction. Now we are going to consider another case. Here there is a conical flask. In that conical flask we are taking zinc sulfate and we are taking iron. We are adding this iron to zinc sulfate. You need to always remember that iron is less reactive than zinc. In the reactivity series, the position of iron is at the bottom compared to zinc. Zinc is more reactive. So let's see what is going to happen here. We are going to add iron to zinc sulfate solution. When we are adding this iron to zinc sulfate solution, we are not going to see any of the reaction because iron is less reactive compared to zinc. So we can conclude that only more reactive element can replace less reactive element. The element should be powerful, then only they can replace the other element. Here iron is not powerful compared to zinc. In the previous reaction, copper sulfate and iron is powerful than copper. That's why iron is replacing copper from copper sulfate. Here iron is less powerful than zinc. Zinc is more reactive compared to iron, so there won't be any reaction. No change. There is no reaction because iron is less reactive than zinc. Iron is less reactive compared to zinc. There is no displacement reaction. More reactive metals displace less reactive metals from their compound in aqueous solution. Only more reactive metals can displace less reactive metal. If you like this video, please subscribe to my channel and visit our website www.winpointonlineclasses.com. Support us for providing free online classes to everyone. Thanks for watching.